Welcome students. In this video session, I am going to discuss about types and declarations. So the purpose of specifying the type when we declare a variable in programming language is the type whatever you are specifying will be used for type checking, and also it will be used for translation purposes. Let us discuss with some examples. So type checking means when we have an expression, only when we know the type, the compiler will be validating whether the operands whatever we have used in the expression are of same type or not, or the operands whatever we have used whether their types are suitable for performing that operation or not. So this can be validated only if you know the type. So it is for type checking. And what about translation? Only if we know the type, memory can be allocated accordingly. In Java, if it is an integer variable, we have to allocate 4 bytes. If it is a float, we have to allocate 8 bytes. So that can be known only if you know the type. So the application or the purpose of specifying the type is it is meant for type checking, and also it is meant for translation purposes. Okay, fine. So the next one is type expression. So the type whatever we have in our programs, it will be expressed in the form of a tree-like structure, and that is what called as a type expression. So how this type expression is being constructed? The type expression can be constructed either by using basic types or by using basic types along with custom types. Okay, so this is how a type expression can be constructed. Let us see some examples. Now say for example I have a two-dimensional array int 2 of 3, so it means that 2 rows 3 columns. Now how we can express this by using type expression? The first thing is, first we have to define the one-dimensional array. Everyone knows two-dimensional array is nothing but collection of one-dimensional array. Now in our case, when we say int 2 of 3, what does it mean? It means that it's a collection of two one-dimensional array with size 3 each. So first, the one-dimensional array is being expressed array of 3, then integer. So it means that array size is 3, the number of elements in array is 3, and the type of the array is integer. Okay. Now how to have the two-dimensional array? So two-dimensional array, it's once again. So two-dimensional array, its size is 2. Its size is 2. Okay. And what is it? What about its type? It is one-dimensional array. So earlier we defined the one-dimensional array by giving the size as 3 and the type as integer. Now what about the two-dimensional array? Its size is 2 and its type is one-dimensional array. So this is what called as type expression. Now what is the purpose of type expression? When we are compiling the program, what happens is every identifiers, every components in the program will be assigned with some type expressions, and during execution of the program it will be validated by using the type expression. Okay, that's the purpose of type expression. Fine. Then there is something called type equivalence. As I said earlier, when we have an expression, and before evaluating that expression, we should ensure that the two operands or the operands whatever we given for that, or whatever operands we have used in that expression is of same type. When we have an expression like num1 plus num2, num1 and num2 should be of same type. Okay, so how to check whether num1 and num2 are of same type? So we have to check its equivalence. So when the two types can be called as equivalent types, so whatever basic types you have used and whatever custom types you have used for considering the first type, if it is the same for the second type also. Say for example, assume that I have used basic type, integer basic type, and one array type for considering the type 1. Similarly, if I have used the basic integer type and array type for considering the second type also, then type 1 and type 2 can be called as equivalent types. Okay, fine. So we have seen this grammar in our earlier sessions also. So this is a grammar meant for variable declaration. So any sort of variable declaration can be validated by using this grammar. Now along with this grammar, we have a set of rules, semantic rules, and this rule will assign the type. Okay, so in specific, the symbols whatever we have in this grammar, they have two attributes. One is width attribute, another one is type attribute. So type specifies what type it refers to, and width specifies what is its memory conception. Okay, now you can just see here for the grammar b tends to int, for the production b tends to int, we have the width like b dot width equal to 4. Okay, in Java integer takes 4 bytes, that's why b dot width is 4. And similarly here b tends to float, for the production b tends to float, we have the attribute value b dot width equal to 8. In Java float take 8 bytes, that's why. So by using this semantic rule, we can compute the type and also their widths. Okay, fine. So the next one is translation of expression. So whenever we have an expression, that expression will be converted into intermediate representation. That is what 3 address code representation. Now for any expression, for converting into 3 address code, we have a semantic rule for it. So by using the semantic rule, we can generate the 3 address code. Okay, now as you could see in this example, for the grammar, whatever, for the production, whatever we have in the grammar, we have an associated semantic rule for it. Now using this rule, we can generate the 3 address code. So 3 address code is an intermediate code representation. There are many intermediate representation, but the 3 address code intermediate representation is very close to target code. Okay, so by using this semantic rule, we can just generate the 3 address code. Now you just see there, when we have a grammar like s tends to id equal to e, for the symbol s we have an attribute called code. Even for e also we have attribute called code. So s dot code equal to e dot code. Okay, so code attribute has the 3 address code. The code attribute has a 3 address code. Now how we are generating the code? By using the function gen, we will be generating the 3 address code. Okay, so by using this grammar only, by using this grammar along with this semantic rule only, we will be generating the 3 address code. Okay, so I hope it is clear for you. Now there is one refinement in this. In addition to code attribute, we also have an attribute called address. Okay, so what we'll be having in address? In address, we will be having the location where we have the 3 address code. So wherever we have the 3 address code for a particular sub expression, so that address will be there in address attribute. Okay, you could see here, if the point whatever I said is not clear, you just go through this example, it will be very clear for you. So e dot address equal to new temp. So it means that when we have an when we are applying this production, then it means that e dot address equal to new address. You're just creating a new address. Now next what you're doing is e dot code equal to e1 dot code and E2 dot code. Then using this E1 code and also U2 code, you are generating a new code. E dot address equal to, the new code is E dot address equal to E1 dot code plus E2 dot code. E1 dot address plus, in the address what you will be having? You will be having only the code. So that code you are just having it here. Okay, so we have two attributes. One is code, another one is address. Code is meant for having the three address code, whatever code we want, or whatever three address code we have for the expression. So that code, and address, in whichever location we stored that three address code, that location will be there in address attribute. Now the refinement for this translation of expression is that instead of generating or instead of storing the code here and there, we can generate the code sequentially. Okay, we can generate the code sequentially. That is a refinement. Okay, you can just see here the same grammar or same semantic rule. Only thing is that here we are not using the code. Here we are not using the code attribute. Instead, we will be generating the code sequentially instead of explicitly storing it in some location and using it for future purpose. We will be generating the code sequentially. Hope it is clear for you. Okay, fine. Then the types are also needed for addressing the array elements. When we have an one-dimensional array, how will be referring the individual element? Say for example, you want to access a fourth position element. So how will you access it? So once if you know the base address in the sense address of the element present in 0th position. Array's index value is starting from 0. So whatever element you have in 0th position. So that element's address, that is what we are calling as base address. The 0th position element present in some address, and that address is what base address. So once if you know the base address, with that base address and the size of every element, okay, if it is an integer array, in Java integer take 4 bytes, right? So if base address, if you know the base address and if you know the width of every individual element, then you can find any position elements. To be specific, if you want the fourth position element, so base address plus 4 into width of each element. If it is an integer array in Java language, the width of every element will be 4. So base plus I into 4. So by using this, you can find the element directly. Instead of sequentially accessing the element, directly you can find the element. Suppose in case of two-dimensional array, if you want to access element directly, even that is also possible. So you can locate the element present in the two-dimensional array directly by using this formula. Okay, so base plus I1 into W1 plus I2 into W2. Say for example, if you want the ith row element and jth column element, then what you have to do is base plus I into width of each row. W1 stands for width of each row plus j into width of individual elements. Okay, I'll repeat once again. If you want ith row element and jth column element, then you can locate the element directly by using base plus I into width of the row, width of each row, plus j into width of every individual element. Okay, so by using this, you can just locate the element directly. Suppose if the array element is not in the array's first element is not in 0th position, okay, then by using this formula, you can locate the element directly. Okay, earlier the two cases we considered that array element present in the array's first element is present in 0th position. Normally in C language, C++, and also in Java, the first element will be in 0th position. The index value starts from 0. Okay. So we need not worry about this one. We can locate the element just by referring these two notations. Okay, fine. So the next one is how the array elements are being stored in the system. So array elements will be stored in continuous location. Only if it is stored in continuous location, we can identify the or we can locate the element directly by using the formula whatever we discussed in our earlier slide. So array elements will be always stored in continuous locations. But there are two ways of storing it. One is either it can be stored based on row major or it can be stored based on column major. You can just find the difference. Row major in the sense the elements will be stored row wise. First row will be stored, second row will be stored, third row will be stored, and so. So row wise element will be stored. That is what called as a row major. Column major in the sense elements will be stored column wise. First column value will be stored, second column value will be stored, okay, third column value will be stored, like that. Okay, here if you see first column value gets stored, second column value will get, then third column. So column wise it will be stored. So if it is stored like this, it is called as column major. Okay, any programming language, it will be choosing either row major or column major. If you take the language like C, C++, Java, they will be following row major. The elements will be stored based on row major. But if you take a Photon language, here the elements, the array elements will be stored based on column major. Okay, fine. So as I said earlier, if you want to perform the type checking, how it can be done? For every component in the program, a type expression will be assigned to it, and during execution of the program, the component will be validated based on the type expression. So that is how will be validated. And there is something called sound type system. So sound type system, what happens is when we go with sound type system, it will be eliminating the need for dynamic checking for type errors. So we need to check only during compile time, and during runtime we need not check because there is no possibility of getting any type errors during runtime. So such type is what called as sound type, and the language can be called as strongly typed language if the compiler guarantees that there is no possibility of getting any runtime error. Okay, so if a language ensures that there is no possibility of getting any runtime error because of types, then the language can be called as a strongly typed language. Okay, so strongly typed in the sense there is no possibility of getting runtime error because of types. So this is what strongly typed language. Then rules for type checking. So how we are going to check the types, or how we are going to infer the types. So we can infer the types by using two approaches. One is by using synthesis type and by using inherited types or inference types. Now let us see it one by one. Synthesis type in the sense we can infer the types of a particular component by the type of its sub-expression. Okay, so you can just infer the type of an expression from the type of its sub-expression. Okay, I'll make it clear with a simple example. Now just consider that you have a function for which you are giving the input of type S and the function is returning of type T. So S is a type of the input we are giving for the function f, and T is a type returned by the function f, and X has type S. Okay, you are just having one input called X and X type is S. If this is the case, then whenever you call f of x, obviously the return value will be of type T. That is what I said. When the input type is X, sorry, the input X is of type S, then the return type will be T. Okay, so we are just inferring the type of f of x by the type X. Okay, so this type of inferring the type is what called as synthesis type. Next we have inference type. Here you will be inferring the types from the way it is being used. How it is being used. Based on that, you will be inferring the type. Here I have just listed one example. Just see here. If f of x is an expression, we have an expression like f of x, then you have some attribute, some type alpha and beta, and f has a type alpha tends to beta. So it means that f type is, it is accepting the input of type alpha and it is returning of type beta. Okay, so if this is the case, then obviously x type should be alpha. Okay, I'll repeat once again. We have a function f, okay, and for the function f, you have defined the function f with an input of type alpha, and the function is returning of type beta. Okay, fine. Now if you give x as an argument to the function and x argument as an argument to the function, obviously x type should be alpha. So that is what type inference is. Still, if you want to make comfortable with synthesis type and also inference type, the languages like C, C++, Java, they follow type synthesis. So it means that whenever you use any variable, prior to that you have to declare that variable. If you are using a variable, prior to that you have to declare it. But whereas languages like Python, there is no need for any declaration. You need not declare any variable. Based on the value you are assigning, it will be taking the type accordingly. So Python follows type inference, whereas the languages like C, C++, Java takes type synthesis. Okay. So what does it mean? Synthesis means it will be taking the type based on its sub-expressions. Whereas type inference means how you, it will be taking the type based on how you are using it. If you are assigning an integer value, then it takes a type integer. If you assign boolean value, it will be taking the type boolean. So that is what type inference is. Okay. Then the last topic is type conversion. So we already aware of it. Whenever we have an expression, all the operands should be of same type. If one of the operand is of different type, then obviously what happens? That type will be converted to type of the another operands type. When we have num1 plus num2, if num1 and num2 are of not of same type, then what happens? Either num1 type will be converted to num2 type or num2's type will be converted to num1 type. This is what called as type conversion. So there are two type of conversions. One is implicit conversion, another one is explicit conversion. In programming language, we might have learned a term called typecasting. Okay, so converting value from one type to another type is what called as typecasting. So there can be two type of typecastings. One is implicit, another one is explicit. Implicit in the sense the conversion will be done by the compiler itself, and explicit means the conversion will be done by the programmer. Okay, so implicit conversion or explicit conversion. Okay, so when we convert the value from one type to another type, the value may be while converting the value from one type to another type, there may be a loss or there may not be a loss. When you convert value from one type to another type, there may be a loss in it or there may not be a loss. If there is a loss, it is what called as narrowing conversion. If there is no loss, it is what called as widening conversion. When you convert an integer value to float value, there will not be any loss. Why? Because integer's memory consumption is 4 byte and you are converting it to float byte. So 4 byte value you are representing in 8 byte location. So when you convert or when you store a value which is in 4 byte, when you store it in 8 byte location, obviously there will not be any loss. So such conversion can be termed as a widening conversion. And there is another type, that is narrowing conversion, the vice versa. That is when you convert a float value to an integer value. When you try to store a value what you have in 8 bytes to 4 bytes, obviously what happens, there will be some loss in the information. So such conversion is what called as narrowing conversion. So these are the hierarchy of widening conversions. We have to move from bottom to top. Okay, so when you convert the value from byte to short, short to int to long, long to float, and float to double, there will not be any loss. So this conversion is what called as widening conversion. When you convert it from top to bottom, that is what called as narrowing conversion. Okay, fine. So all the implicit conversions, all the conversions done by the compiler, it will be of widening conversion. Okay, so widening conversion. So the implicit conversion is also called as coercion, and explicit conversion is called as casts. Okay, and repeating the point once again. All the conversions done by the compiler, it will be of widening conversion. Is it okay? Fine. So whenever we have an expression, the semantic rule will be in such a way that the value whatever we have in an expression, that will be converted accordingly. When we have an expression like num1 plus num2, we will be having a semantic rule for evaluating this expression, and that semantic rule will ensure that whether the types are equivalent or not. If they are not equivalent, obviously the semantic rule will ensure that the conversion will take place. The widening conversion will take place. So for implementing that, we need two functions. One is max function, another one is widen function. Max function, it takes two types as input and returns the maximum of the two types. When I pass integer and float as an argument, max of int comma float, I will be getting the result as float, because float's memory consumption is greater than integer's memory consumption. So that is what max is. And next one is, you have a function called widen. So what this widen function will be doing is, it will be converting the value present in address A from type T to type W. Okay, you will be giving an address as a first argument. So what happens is, the value whatever we have in that address, that value which is of type T will be converted to type W. Okay, so this is what happens. So this is a semantic rule. Now if you have an expression like E1 plus E2, so what happens? The maximum of this two type is being computed, then it is being widened, operand 1 also widened, operand 2 also widened. So we are just calling the function widen. The notable point is that when T and W is of same type, then widening will not be performed. I'll repeat once again. When you say a comma int, then what happens? The widening operation will not perform, because second type and the third type, second argument and third argument, both are integers. So the point is, T and W, when they are of same type, then widening operation will not take place. Okay. So, and this semantic rule will be applicable even if both the operands are of same type. Okay, if both operands are of same type, then the widening rule will ensure that the conversion will not be performed, because as I said, when you say int a comma int, obviously conversion will not take place. Only if T and W are of different type, the conversion will take place, the widening operation will take place. Okay, so by using this rule, the type conversion has been implemented. Thank you, students.